In the introductory part, I will discuss and define rocks, as well as I will differentiate this term with the minerals. So we have to understand the differences between rock and minerals in the introductory part. Okay, because more than two minerals often form the rocks. When you look at the rock structure, the rocks are made up of minerals basically. So basically we have to understand in the introductory part the differences between the rocks and minerals. Further, I will explain basic minerals. So I will classify the mineral classification, I will discuss, and this is the introductory part. Further, I will classify the rocks, classification of rocks. Classification of rocks. In this section, I will discuss about the three major rocks. Igneous, sedimentary, and metamorphic. Further, when you go through the nature of the question, when you find out the questions of the previous year, then you find out that separately this may be a topic. So here we have to cover these rocks in details. So further I will explain all these rocks independently, and under that, say for example, if I will discuss the igneous rocks, then under that I will discuss what the feature and the formation, some characteristics, features, classification, examples, and significance in landform development. Landform development. So this may be the structure for all the types. When I will cover the sedimentary rocks also, I will discuss about the formation of this rock. Then I will discuss about the characteristics, feature, the chemical composition, and all the feature, the hardness and the softness, means the structure, structural features also. So I will discuss about the chemical composition, the structural features, okay. And then I will classify the sedimentary rocks also after igneous, and then I will put some examples of that rocks, because example based questions may be asked in examination, especially in the preliminary examinations. So we have to cover a few examples, and then I will discuss the significance of these rocks and how these rocks play very significant role in the landform development, okay. So I will follow this structure for all the rocks, okay. For igneous, for sedimentary, for metamorphic, similar structure I will follow, okay. So then you feel very comfortable when you get the questions from these topics. Later I will discuss about the rock cycle. The next feature I will discuss about the rock cycle, okay. These rocks are interconvertible. ये rocks जो हैं वो convert हो जाते हैं. The igneous converted into sedimentary itself converted into further sedimentary or metamorphic. The igneous converted into metamorphic. The metamorphic rock change and form the sedimentary. So this is known as the rock cycle. I will explain further the rock cycle, and then we will conclude and discuss some previous year questions. And then what is your duty is that you must practice the previous year questions of pre as well as mains and try to write the answers. So previous year questions, and when you look at the previous year's questions of these topics after finishing, then you have to practice some model answers also. So model answers, this will be the coverage. Now I will cover like that. This will be the structure for this topic, like that I will cover. So let's start our journey to understand the rocks. So when we look at the introduction of this part, how we can understand. Earlier I had discussed about the structure of the earth as well as the structure of earth's crust separately. I had discussed the origin as well as the evolution of the earth crust also in my previous lecture. I had used the word lithosphere earlier. What I have written here, that the materials of the crust or the lithosphere are generally called as rock. So basically, what are the rocks when you look at and where it is found? So the outermost layer of the earth is known as crust. Earlier what I have told you people, that the entire crust, in my previous lecture when I have discussed about the crustal structure or the interior of earth, I had discussed that crust having two parts, the outer or the upper crust and the inner crust. Okay, and here we find what the differences in the density of the rocks. The density of, when you look at the outer crust, is almost around 2.7 gram per centimeter cube, while when you look at the inner crust it is almost around 3. So basically what we find, density difference. Why the density difference? Because the nature of the rocks change, but crust is a solid part. Crust is a solid part. Apart from that, what I have discussed, that the upper part of the mantle, the upper mantle region, the mantle part, the middle part of the earth is known as mantle or the mesosphere, and that part is also divided into two subparts, the upper mantle and the lower mantle. When we look at the upper mantle and the crust is known as lithosphere. Lithosphere. Earlier I have discussed that. This lithosphere are floating over the asthenosphere. Asthenosphere is a weak zone where the rocks are in semi-solid state, plastic in nature, as I have discussed earlier. Asthenosphere. Just for revision, try to understand. What I have written here, that the materials of the crust or the lithosphere, the crust or the lithosphere, crust is the uppermost layer of the earth, and when we use the word lithosphere, it includes the crust, entire crust plus upper mantle. This lithosphere is a solid structure. It is a solid structure, and this structure is built by the rocks. So, pardon Manish, your voice is not properly audible. Again repeat, please. What is the what I have said, where the asthenosphere is present? यही तो मैं पूछ रहा हूँ ना आपसे, आप बताओ ना मुझे, एस्थेनोस्फेयर के लिए क्या बताया था, किस डेप्थ तक है एस्थेनोस्फेयर? अगर वो आपको पता है तो आपको पता लग जाएगा ना कि लिथोस्फेयर का डेप्थ कितना है. हैव यू रिवाइज्ड द प्रीवियस लेक्चर? वो पढ़ा पहले जो मैंने कंटेंट दिया आपको, या बनाया डायग्राम मैंने बताया था कि कितना डेप्थ है?
चेक कर रहा था तो उसमें था नहीं, इसलिए मैं पूछ रहा था.
नहीं, उसमें था. ठीक है, ओके. व्हाट आई हैव सेड. हाँ, बोलो बोलो. योर वॉइस इज नॉट प्रॉपरली ऑडिबल मनीष.
Sir, lithosphere consists of total crust and some part of upper mantle, or total upper mantle.
The part of the upper mantle.
Okay.
Okay. So now when you look at this word lithosphere, why we use the word lithosphere? The literal meaning, when you find out the literal meaning of lithosphere is the rock sphere. Rock sphere. Why? Because lithos, the word lithos means the rock. So basically this entire structure, the crust and the upper mantle, are basically the solid structure which is made up of rocks. Now, so where the rocks are available in the solid structure? In this part of the earth. Now when you look at the rocks, or the smallest component of the crust or the lithosphere, what I have used the word elements. Means the smallest component are the elements. So there are variety of elements are present in the rocks, because this crust or the lithosphere are made up of rocks, and the smallest component of the rock is known as element. So further I will explain which element is abundance, which element is in abundance in the earth, as well as in the upper part of the earth, that is the earth crust. So further I will explain what the availability of the elements in the earth as well as in the earth crust. Means when I am talking about earth, I am talking about the entire earth, and when I am talking about the crust, means the upper layer of the earth. So I will give you a comparative idea. Here I had mentioned that in the entire earth, in the whole earth, when we look at, when you compare the entire earth, which element is abundant? 8 most abundant elements in the entire earth are the iron, oxygen, when you look at silicon, magnesium, nickel, calcium, when you look at here sulfur, ammonia. These are the most abundant element which is present in the entire earth. I have used the word whole earth. Okay. But when you look at, and it constitute 99%, these 8 element occupy 99% of the total mass of the entire earth. Okay, 99%. So when we compare the entire earth, so in entire earth 8 elements are in abundance and form the entire and the whole earth, and it occupied 99% of the total mass. Okay, 99% of the total mass of the earth. While when we talk about, look at, whereas 4 elements, iron, oxygen, silicon and magnesium, out of these 8, that 8 elements occupies 99% of the mass of the entire earth. Out of these elements, 4, iron, oxygen, silica and magnesium, what it occupied 90% of the mass. So when we talk about the entire earth, the iron, oxygen, silica and magnesium, these 4 elements occupied 90% of the mass of the entire earth. So according to, earlier I had discussed the classification of the layer of earth based on the Edward Swiss idea, and what the Edward Swiss stated that the first outermost layer according to the Edward Swiss is Shial, then Shima and then Nephi. When you look at the Edward Swiss classification, then he classify the strata of the earth into 3 layers, Sial, Sima, Nephi, based on the elemental abundance. Which element is abundant in the upper layer? Silica and aluminium, and in the middle silica and magnesium, and in the lower nickel and ferrous. How he probably give this classification? By the abundance of the element which is present, but later I have said we find the anomalies in this classification. That's why today we follow the classification in the modern classification. We use the word crust, mantle and core. Okay, but when you look at what I have said, that when you look at this, silica is again very abundant element, and as I have said, silica is abundant, magnesium is there, iron is there. So iron is there, magnesium is there, apart from that oxygen is also there. Because when you look at the minerals, later when I will explain minerals, what you find here, that silicate minerals are abundance in the earth, especially the earth crust. When you look at silicates minerals, means the silica oxides are present. So these 4 elements occupies or comprises 90% of the total mass of the entire earth, and this is very, very important questions for your preliminary exam. Very, very important question. So 8 elements are the most abundant element in the planet earth when we talk about the entire earth, and out of that, when you look at, the 4 elements comprises 90% of the mass. Okay, this is important and significant fact you should keep in mind. Now when you look at, when we talk about the crust, then what we observe here in the crust region, and crust is the outermost part, the uppermost part of the earth, the uppermost layer. So here the 8 most abundant element when you look at, which constitute 99% of the mass, are oxygen. So oxygen is again abundant element in the earth crust. Silica is also abundant in the earth crust. Then aluminium, iron, magnesium, calcium, potassium and sodium. These are the elements which is abundant in the upper layer of the earth, that is known as crust, which these elements comprises 99% of the total mass of the crust. I am talking about the crust here. Earlier I had discussed about the entire earth system. So you should keep in mind the differences of the elemental distributions in the entire earth system as well as in the upper layer of the earth, that is known as crust. Okay, because it may be a question, especially in preliminary examination, or you have to be differentiate between the entire earth and the earth crust. Okay, on the elemental skills, abundance of elements. So look at the flow chart. Here I had given you a flow chart. Here you can compare. Okay, when you look at this flow chart, here what I have written here, the whole or the entire earth, and here in this side what I have written, the earth crust. When you compare this, what we observe here in this comparison, that in the entire earth the most abundant element is the iron. The most abundant element is the iron, which comprises 35% of the total mass of the earth. 35%. While when you look at the earth crust, the most abundant element is oxygen. Let's compare. Oxygen is also present here, but here the percentage, when you look at the 30%, the second most abundant element is it in the entire earth, while the second most abundant element here is the silica, 28%. Silica is also present here, but the percentage, what we find, the differences. The third most abundant element in the crust is aluminium. Okay, so apart from that, iron is only 6%. Here the iron in entire earth is 35%. So basically where the iron is more, in the mantle and the core region, not in the crustal part. What is the most abundant element in the crustal part? As I have said, oxygen. So basically this table you have to keep in mind, because from this table directly you get the question in preliminary examinations. Okay, and this table support you, help you to write a good answer in mains. Okay, because once you understand the differences in the composition, that will support you. Okay, so keep in mind these facts, which is again very, very important and essential for you. Now, after going through this comparative charts, let's understand what I have said earlier, that we have to find out the differences between the minerals and the rocks. Okay, what I have said, that the lithosphere, that is the crustal part, and the upper mantle part is a solid structure and made up of rocks. Now, what is the difference between the rocks and minerals? Okay, when we talk about the minerals, let's understand. Now, these are the naturally formed materials within the earth. The minerals are. So, what I have used the word naturally formed solid inorganic substance. Okay. So, what is the properties of the minerals when you look at? It is an inorganic substance which is naturally occurred in the earth. So, minerals are present in the earth which forms naturally, and these are the inorganic substance, not the living and the organic product or the organic substance. Is it inorganic or the earth substance? That's why it is known as earth substance or the inorganic in nature. Okay, what is the characteristics? The crystalline structure, crystal structure, and a unique chemical composition. The minerals having the unique chemical compositions, and largely the mineral having the crystal structure. Okay, so when you look at, so how we can define the mineral is a naturally occurring substance or inorganic substance within the earth, okay, having the unique crystal structure as well as chemical composition. Further I will explain the chemical composition of few minerals, okay, and I will further classify the minerals, so don't worry about it. Now what I have said earlier during the introduction, that it is introductory part itself, that more than two minerals forms what? The rocks. So what I have said, that usually two or more minerals are organized to form the rocks. So rocks are the product of the minerals. So basically what I have said, that when you look at the minerals forms the rocks, and the minerals are inorganic substance. Inorganic substance which is present in the earth. Okay, this inorganic substance having specific chemical formula, or you can say a chemical composition. These minerals are made up of unique elements, those who are in a proportion, fixed proportion. Now these minerals are present in the earth in the form of what? When you look at ores, in the form of ores, okay, say for example hematite, is an iron ore through which you extract the iron. So basically the minerals are present in the earth in the form of ores. We extract the ores from the mines, as well as then what we did, processing, because these ores having impurities, and we remove the impurities, and then after removing the impurities we extract the desired product. Okay, that is the minerals. So you have to understand this concept, that the rocks are the product of minerals. Now when you look at in the earth crust, what you find here, that there are different groups of minerals are present within the earth. The most important are silicates, then carbonates, sulfide, and the metal oxides. So when you club the minerals, we can club the minerals into two heads. Okay, the non-metallic and the metallic. The minerals are of two types which is present in the earth, the non-metallic and the metallic. The sulfur, the phosphorus, when you look at, okay, these are non-metallic, while the iron, the nickel, okay, these are the metallic minerals. When you look at the non-metallic, we can say silicates, carbonates. These are the groups of minerals or sulfides. Okay, further I will classify the silicates. The silica is there, okay, and the oxygen is there in the silicates. When we talk about the second, carbonates, made up of the carbon and oxygens, basically the carbonate compound. Sulfides, these are the sulfurs. The sulfur is present in these minerals, sulfide groups. Okay, metallic, when we look at the metallic minerals, the ferrous, where the iron is there, and the non-ferrous, where iron is absent. Okay, so when you look at the non-metallic minerals like lead and zinc, okay, these are the non-metallic minerals when you look at. and the mica, when you look at, is the non-metallic minerals. Okay, when you look at here, and now when you look at the silicates, the first group of the non-metallic minerals, when you look at the silicates, in silicates the most abundant mineral is the quartz, and quartz are very hard. When we talk about the quartz, it's very resistant mineral, and crystalline in structure. What is the feature of the quartz? Very hard to weathered, resistant it is, and crystalline, and it is also known as silicon oxide. So what is the most abundant element in the quartz? It's silica and oxygen. So when we talk about the silicate, in the silicate the most abundant mineral is the quartz. Quartz is a mineral which is present in the earth, and when you look at the composition of the quartz having the silica and oxygen, it is known as SiO2, okay, silicon oxide. What is the property? As I have said, it is one of the hard and resistant mineral which is present in the earth crust, and when you look at, it is crystalline in structure. Now when you look at other silicate mineral is the feldspar. Here also when you look at the feldspar, here also the silica and oxygen is present. It is one of the abundant mineral which is present in the earth crust, feldspar. So quartz, feldspar, all are the silicates. Silica and oxygen is there. And the third silicate minerals which is present is the ferromagnesia. What is present here, the most abundant element in the ferromagnesia is the silica and oxygen is common in all silicates. Silica and oxygen is common. The proportion may vary of the silica and oxygen, the proportion vary. But apart from that silica and oxygen, the iron and magnesium is also present in the ferromagnesia. So if someone is asking you what are the, in this group of minerals, silicates, what are the most abundant minerals which is present? The quartz, the feldspar and the ferromagnesia. These are the minerals under this group, silicates. Now when you look at the carbonates are made up of the carbon and the oxygen. When you look at the carbonates, then the calcite is the most abundant what? Mineral. The calcite, when you look at the calcium is here in the calcite, carbon and oxygen is also present, and the oxygen and calcium is the most abundant in the calcite. So carbon is also there. So when you look at calcite is a carbonate mineral. Okay, further I will explain it. Now when you look at sulfides, here what we find as a mineral? Pyrite. Say for example, when we talk about cuprite or copper pyrite, okay, copper pyrite, it is an ore through which we extract the copper. Okay, so here when we talk about Cu2s, sulfur is there and copper, so through which, this is the ore through which we extract the copper. So what we find here, the mineral is pyrite. Apart from that, iron sulfide is also there. Iron and sulfur is present. Okay, so in this group of minerals, when you look at, this is the group of minerals. There are three group of minerals: silicates, carbonates and sulfide, and out of this is the most abundant what? Mineral is present. This mineral form this group. Okay, and what I have said, in this mineral the sulfur are present apart from other element. In this, apart from that, iron is present, and here in pyrite the copper, if mix the copper pyrite for example, through which you can extract the copper through metallurgical processes. Okay, and further, as I have said, metallic, we can define the ferrous where the iron is in abundance, and where the iron is not present, the non-ferrous. Okay, the non-ferrous minerals like phosphorus, as you know, and the lead, zinc, all these is the non-ferrous. Phosphorus is, you can say, non-metallic. But when you talk about the metallic, okay, the plumbum, as we call it, lead, the zinc, these are the non-ferrous metallic minerals. So we can club this. So further, what I had defined the minerals, and these minerals forms the rocks, and I had given you the properties of the minerals. Minerals are of two types, non-metallic and metallic, and when you look at non-metallic, there are three groups of minerals, and in this three group of minerals, what I have said that this largely made up of such minerals. Okay, so you should keep in mind this classification. From here you can get the question. Okay, now let's move forward. Is there any doubt? Is there any doubt? No? Okay. Now, further, let's understand some basic significance of the rocks. Why we are learning the rocks? What is the significance of the rock? As I have said, the rocks are the major component of the lithosphere. The lithosphere are basically made up of the rocks. It is known as rock sphere because the literal meaning of the lithos means the rock. Okay, so now when you look at the significance of the rocks, as I have said, it play very important role in determining the characteristic feature of the several type of erosional landforms. Further, I will explain the erosional processes. Okay, erosional processes. Okay, because when I will explain the landform development, then I will explain the factors which affect the landform development, and in that factor I will explain the geomorphic processes. Geomorphic processes, such processes which change the outer structure of the earth, geomorphic processes. And out of that geomorphic processes, there are two processes: endogenetic, some processes which originate within the crust but it carved out and shaped the outer structure also, and one process is very active, it is known as exogenetic, which originated over the earth surface and it modifies the landform. Okay, so what I have said that a rock play very important role in determining the characteristics feature of the erosional landforms. Okay, if the rock is very hard, hard rock is present. Okay, then it resists the erosional activities or processes. It resists, but if the rock is soft, then erosion is easily takes place by the forces of erosion through the process of erosion. So basically what I have said that the rocks important, these rocks, when you look at the nature of rocks, the characteristics feature of the rocks play very significant role in the erosional processes and shaping in the landform in an areas. Okay, so when you look at the regional scales, what you observe here, that these rocks play very significant role to determine the landform structure. लैंडफॉर्म और लैंडस्केप के फॉर्मेशन में रॉक्स का एक बहुत इम्पॉर्टेंट रोल है. नाउ आई हैव मेंशन दैट अ वेरी फेमस डिक्टम. फर्दर आई विल एक्सप्लेन the contribution of this geographer W.M. Davis because it is in syllabus where you have to learn the geomorphic cycle of erosion. So when you look at a US geologist and geomorphologist, geographer W.M. Davis, what he said that the landscape is a function of a structure, process and a stage. Now when we look at the stage represent time. Okay. So what he said that the landscape, who stated that? W.M. Davis, and Davis is in syllabus. Pink and Davis geomorphic cycles you have to learn. Further I will explain in geomorphology that how the Davis explain the geomorphic cycle, which is also known as the normal cycle. So what he emphasized that when you go through and when you find out any landscape, the landscape are the function of a structure. A structure means what? A structure is a very big term, later I will explain, but a structure according to him as a rock structure basically, or lithology. But apart from lithology, this word having expanded connotation, because it also, this term structure also represent other features of this, okay, like bending, folding, all these features comes under structure. Second, process, and third is the stages all the time. So landscape are the time dependent and are product of the processes, endogenetic and exogenetic, and structure. So W.M. Davis also believes that structure, that is lithology, play very significant role in the formation of landscape. So W.M. Davis also emphasized the significance of rocks and their role, significant role, what in carving out the different landscape in an area, or you can say a unique landscape feature in an area. Okay, now different landform in an area form a landscape. So when you use the word landscape, landscape is a broad term. When you look at any area, what you find of different features, the mountains are there, the valleys are there, okay, the river are flowing in the valleys and carving out where from the peak of the mountains the glaciers are flowing downward. This is known as the landscape. So when you visualize any landscape, so in the landscape there are different landform and that are product of the structure, process and stages according to W.M. Davis. So here the lithology means the rocks play very significant role according to the geomorphologist and geologist geographer W.M. Davis. Okay, so now what I am discussing right now, the significance of rocks. So when you look at another geographer, A.K. Loveck, what he has stated that a rock should be conceived as a product of its environment. When the environment is changed, the rock changes. What he correlate the relationship between the rocks and the environment. What is environment? The surroundings, where the rocks rise. There are multiple factors which is active in a specific environment. These factors are both abiotic and biotic. non-living and living factors are active in your surrounding. So where the rocks is present, in the vicinity of rocks, what we find, the environmental factors are active. What are the environmental factors which are active? The abiotic means the non-living. What are the non-living factors? Like temperature, pressure, humidity, precipitations, okay, winds, water. There are lots of abiotic factors which is active there. And the biotic, that is the living factors are there. Living factors, the flora and the faunas are there. Flora and faunas are there. So what these factors carved out, once the environment change, in the changing, if the abiotic factor change, the temperature change, the pressure change, the humidity change. Further I will explain the weathering process. What is weathering? The disintegration of rocks is known as weathering. Okay, so weathering process begins once the environment change. What we find that the changing conditions led to change in the rock structure. Okay, so according to the Lobeck, the environment and the rocks, when you look at having a relation, the changing environment led to the change of the rocks. Further I will explain, is that this statement is correct or incorrect. Further I will explain, so don't worry, but let's understand the significance. Now rocks are also play very significant role in find out the age, okay, in the dating. What I have written here, helpful in the dating of the age of the earth, as the rocks are the books of the earth history and fossils are the pages. Okay, when you look at a specific rocks like sedimentary, when you look at in the sedimentary rocks, between the strata, between the layers, sedimentary rocks are the layered structure. What we find here is the fossils deposits, and the fossils gives us idea about the what, in what ages of the earth, which kind of species is present. So when you look at the rocks, when we collect the rock sample and when we dating, okay, by use of the radioactive elements like the carbon dating or the argon datings, okay, to calculate the ages, we can find out the age of the rocks. So it gives us idea about when these rocks are formed, what was the condition during that period of time. So we can observe by analyzing the rocks. So rocks gives us ideas about the geological structure and the geological time scales. It gives us idea. Now what is the another significance according to S.W. Woolbridge and R.S. Morgan? When you look at this, what this geographers' opinions about the features. They remark that rocks, whether igneous or sedimentary, constitute on the hand the manuscript of the past earth history, on the other the basis of contemporary sceneries. What I have said earlier, that the rocks play important role in the dating the age of the earth. To calculate the age of the earth, geological time, we develop the geological time scale, and the one source is the rocks also, because the rock datings as well as the fossils studies, earlier I had already discussed in detail how we had created this geological time scale. Okay, it gradually evolved as our understanding clear with the time. It gradually evolved, geological time scale. Earlier I had discussed in detail how the geological time scales designed and developed. Okay, so here the rocks. So what I have said, that what is the opinion of Morgan and Woolbridge, that the rocks, whether igneous or sedimentary, constitute what, the hand, the manuscript of what? The past earth. Means the rocks gives us ideas about not only the past earth but also about the contemporary scenery. So the rocks, according to this geographer, gives us idea about the past as well as present. We can get the ideas, okay, because with time the environmental conditions change, the factors change, okay, over the earth, and that change led to what? It left the imprint over the rocks. The rocks also affected due to that changes. So the rocks not only gives us idea about the past but also the present, what kind of changes is going on, okay. As I have said that what is the impact of the environmental conditions. As I have said, one process which is very active is known as weathering, that is disintegration. One process which is very active is erosion. There are various erosional agents like wind, water, glaciers. They are having the impact on the present rocks, okay. Deposition, another process is deposition. So these are the processes which is active, and these are the processes which is impacted by the environmental factors. So when you look at the rocks gives us ideas not about the past but also the present, contemporary sceneries, okay. So these are the significance of the rocks study. When you go through the study of the rocks, you get the ideas about the different landscapes, their feature, the changing scenario, the ages of the rocks gives us idea about the geological times, the fossils studies, the fossils which is present within the rocks, that gives us idea about what present in which time after the in the evolutionary stages of the earth, okay. So this is the significance of the rocks, and that's why we are studying. So you should keep in mind this significance.